Okay, let us get started. What tactics do we have? Well, we only have RFL, so not much else we can do. We have exact and we have assumption. Exact H. We have rewrite. Rewrite H. Rewrite G. And we're done. Rewrite. This rewrite or apply? This is exact. What is first arg? First arg is 4, right? And second arg is H. H4. Hang on. First arg is cancelled from both sides. Second arg is this. Okay. Moving on. What tactics do we have? Assumption, exact, rewrite, and RFL. Exact HP. Exact P to Q dot MP of HP. Control H, exact H. Proof by cases. Cases H, and then we have exact. Exact HPR is H1, and then we have exact HQR is H1. Logical equivalence. P same as Q dot MPR of dot MP. H is P. H and P applied HP. Okay. This gives us a Q. Oh, we don't have exact. No, we do have exact. Okay. Just pushing on. Case H. We don't have cases H. This is going to be assumption. This one will be H and Q of H1. Source diagonal of all this, and then we put an exact in front of it. True or exact or dot. I was expecting something tricky on that one for some reason. P and not Q. Not P and not Q. We have not or. Okay. Case H. Actually, wait, why are we casing H? This is just assumption. Okay. Not and or. Again, do we have not and? Oh, wait a second. Okay, I should not have been allowed to use that. Why was I allowed to use that? The simplification theorem to use this. I don't get it. So I'm allowed to use this theorem. But it proves the exact thing of... Am I allowed to use this? Well, the hint says the simplification theorem to use is that. So I guess I'll just use it. This is crazy. Not or. There's something wrong that feels wrong about this. But moving on. It's telling me to use this. Like, I feel like there's something that is not correctly designed on this exercise. Like, maybe it's teaching me to use, when to use these things. Maybe that is the point. Hey, at least we get an error. This is finally satisfying. Okay. That is not satisfying enough. Definitions, tactics. Okay. Zoe and Mel. What tactics? We don't have apply. That's annoying. Constructor. Actually, what are the hints? Wait, hint is the first proof Zoe. Let's do a contradiction. HCN. And then we can apply that now. So have h1 equals stvn.mp of HCN. Wait, we have not Zoe. We have Mel now. And using Mel, we're going to get have h2 equals stm dot mp h1. We get Mel and Zoe. Now we can do contradiction. So exact hcn apply to h2 dot right. Okay, so now we prove Zoe, and we're going to prove not Mel. How do we prove not Mel? So have h1 equals stz.mp of z. This is going to be exact and dot intro of z and h1. Okay, this feels much more interesting. What tactics? Again, we don't have apply. Alright, so we're going to do by have HAN of not A. So if we get an A, how do we get a contradiction? Well, let's just push it through all the equations. So have h1 a dot mp of ha. We get b and c. Have h2, which is going to be stb dot mp of h1 dot left. Okay, and then have h3, which is going to be h2 dot right applied to ha. This should give us false. Okay, next up let's brute force b. So have hbn not b equals intro. I feel like we're just repeating stuff right now. Alright, I'll just write it out instead of copy and pasting. Have h1 stb dot mp of hb. Huh. Maybe this is not as easy as I thought. h1 equals do we have a contradiction yet? I think we do. So let's just do case h1. This will be exact hhp. This will be exact h2 dot h of h2 dot left. Can we get C out of this already? Let's try. Have h1 equals sta dot stan dot mp of han. Have h2 equals stbn dot mp of hbn. I'm sure there's something obvious I'm not seeing here. Screw it. I'll have HCN not C equals phi intro let's just brute force this. Cases H1 apply and well, if we get another not C, but if we get this in here, sac and control. Okay, yeah, this was not a very elegant proof, but we just basically brute forced it. Level 3 of 8. What tactics do we have? Yeah, so I'm sure there's a very clever way of doing that, but to me, the most straightforward way is to just brute force this. So, which there's some theorem here that we should care about. Hang on, I'll be right back. Okay, we're back from the interruption. Right, so I want to apply this to, so I want to use str.mpr and sti.mpr, but for both of these I need Robert, and I have a negation of Robert. And so I'm trying to figure out so I need to flip the this is what I want. Okay, so let's do the first one first. str, we're going to want not if and only if not mpr of this should get us this term here. And then we want to apply the mp of this to Great. Alright, have H2. This is going to be not, if only if not.npr. Apply to STI, and then the NPR of this reply to. Okay. So we have this mess here, and we're just going to simplify it. Rewrite not or at H1. Case is H1. And we should get a contradiction here from one of these. So it should be exact right applied to H2 and HRN. So right and dot intro H2 and I forgot them. H2 and HRN. Okay. So this proved that Robert is true. And then now to prove that Ira is true, we do have H1 equals sti.npr of HR. Great. And now for the conclusion, exact n.intro HR HI. And which one? Okay. Moving on. I'm just going to brute force these because I find, because look, there's 3 elements here, right? So brute forcing, there's 8 possibilities. So let's just brute force. Right, I think we can just brute force Alice. So have okay, now we can apply the 2 to not Gary. Right, and now I think we just push for a contradiction. Okay, and now we just do, let's see, exact h2.np, apply to Alice, and then great. So proving Gary should be straightforward. It's just sta.np is HA. And then proving Xavier should be okay, and this should be exact and.intro h of a and.intro hg hx. I have very inconsistent naming that A is capitalized but G and X are not. But anyways, so brute force works. Let us brute force more. We want to prove A and B and C. Okay, so let's just brute force A. So, as always, we're going to expand everything to find something that goes wrong when this is not satisfied. We want to split this. Okay, and then we want to use this. And not if only if that is 2. Alright, now let us chase a false. So not A, not C, and this should give us what we want. So it should be left. Apply to h2.np of HAN. Great. So we have our A. Let's try to prove B then. Okay, before we do this, we actually want to do something else. We want to exploit the fact we already have the A, so have h1 equals. Okay, so we want to call this h2. Is this enough? Let us just apply cases to h1. If we have a C, then we do h2 dot mpr of the C, and we apply this to HA. Okay, and if we got it to B, we do exact HB and of H. Okay, so we've proved A, we've proved B, and at this point we have H2 equals STB dot MP of H of B, and at this point we should have HC equals H2 dot MP H of A, and we do apply and dot intro. The first one is going to be first one is H of A. Second one is H of B, and the last one is H of C. And we replace apply with exact. Okay, and it worked. We'll continue brute forcing. Have H of A. Wait, I made a mistake. I should fix it. Okay. And Okay, we proved A. Now we're going to prove B. Oh, again, we should take advantage of proving A. So have H1 equals STA of right. We'll use H1 later. We're going to apply it to this. Bam. Okay. A, C. Let's just break this apart. So this is going to be H of H2 dot MP of HA. This is going to be exact HBN of H. Okay. And at this point, when H2 equals HCN equals not if and only if not dot MP R of H2 okay this is going to be a not dot NPR of HA. I can't believe that worked. Okay, so this is going to be apply and dot intro H of A, H of B, HCN. And we have to change this to exact. And now we're done. We'll continue brute forcing until brute forcing gets too complicated. Have A so if we apply right, we want to get a C, and the H2.MPR of HAN will give us a C. Next up, we're going to use this fact here. Okay, proving B. By contra HBN, let's have S2 equals Hey, I think that proves B, right? No error so far. And room proves C. Okay, we have C. So now apply n.intro HA. Damn it, why is this not done? Where did we screw up? What the hell? STAN. Okay, now we're done. Continue brute forcing. Yeah, I'll be right back. Hey, I'm back. Yeah, so this is going to be by contra HAN, and then we're going to have H1, this MP of HAN, not if in. Can we break this apart? How do we break this apart? There's gotta be a way to break this apart. Here also stuff we're supposed to use that we never used. Okay, so this should really just be an OR. And if this was an OR, this would be so much easier. Actually, I'm just going to try to rewrite after this is an OR. Well, wait. A implies B equals not A or B. So why can't we rewrite this as a not or? Can we push neg? We're not allowed to use it. What the hell? What are we allowed to use? The problem here is that we don't have a bunch of if and only ifs. We have strict implication that is in one direction only. So we have and, we have this. Hey, fuck it. We're going to define this ourselves. Have my conversion A imply B if and only if x is equal to not A or B. We get rewrite, right? So we can use it. Right, so we can use this after we prove it. This is obviously true. I just can't figure out how to prove it right now. What am I missing? Fuck it. Hey, exact H, exact right of H of left. Other direction. Hey, we have this mic conversion lemma, which we are now going to use. I don't even remember what we use it on. Damn it. H1. Probably rewrite my conversion at H1. What the hell? I am so confused. Oh, for all A, B. Wait, I should have named this stuff X, Y. Why can't we do this at H1? Why is it being applied to not? What is going on here? Okay, so I'm learning Lean, and there are clearly parts of Lean here that I just do not understand. And we're just going to do something very ugly to push this forward for now. And at some future point, I will care about fixing this. Please fucking work so I can move on from this. Okay, we can move on. Yeah, so I have no idea how the rewrite function tactic, like the internals work. I'm sure there's a simple solution, and sometime in the future I will understand how that works. But for now, we push on. And I forgot what this entire proof's about. Damn it, I've lost my entire track. Wow, we're still just trying to prove A? We've made no progress so far. What the hell? Oh, now I think I remember what I want to do now. I want to rewrite not or at h1. Right, I couldn't do this one simple rewrite, so we do this. Now we're going to do cases of h1, and now we're going to have h2 equals, let's do not at right. Case h2 is going to be stb.np of right. And at this point we have h2.npr of left, and han should give us this. Wow. We have A, and next up we'll have HBN not B by contra HB. We should use this, have H1 equals sta.np of H of A. Rewrite my conversion at h1. Okay, this will come in handy sometime later. H B. So have h2 equals stb dot mp h of b, and now we're going to do the cases on h1. So if we have a C, we're going to do apply h2.mpr of h of ha. Oh no, h2.ha, this gives us a, hang on. Okay. This one here is just exact h of hb. Alright, so we have the A, we have the not B, and then we're going to have H2, which is equal to STBN dot this applied to HBN. We're going to do my conversion at H2. We don't need this because this is an if and only if. Okay. So cases of H1. If we get a C, A, negative B, and C, it's going to be exact and dot intro H of A and dot intro HBN HC, which proves it. In this case here, it's going to be exact false dot intro HBN of H. And I made a silly mistake. A not B, HCN equals yeah, not going to try to be clever, just going to try to finish this really quickly now. Wait, what? H2.mp. Okay, this finishes it. Back and dot intro, H of A. All right. I'm going to take a short break before the last one. All right, let's try the last section of this world. What's going on here? Like, oh, hey, this is gonna be a bit tedious. Not fun. Level 2. I'm very tempted to just copy and paste the previous level. That proves it. Okay. This is going to be just tedious. Do we get new tactics? We get a knave to... Bam! We just proved this thing. I'm trying to invoke it. What the heck? Why do I... What is going on here? It's right there, DSL. Oh, I don't think I passed the A. That's inferred. What is wrong with false started lib? Why can't I do that? No, okay. Clearly this whole thing glitched, but now works. Come on, why is the lean server not starting? You've gotta be kidding me. Wait. Clearly shouting at the computer works. Okay, now I have something useful. Not or H1. Okay. sided limb. I am so confused right now. Okay, this works. Then and dot intro HAA. All right. Continue brute forcing. Why is it so slow? Alright, I can't believe that worked. Okay, that worked. 8 more brute forcing left. I feel like I can automate this at this level. Oh crap, wait, what? Does it prove A is not knight? Huh, this is interesting. Well, that means it's a knave. Okay. Alright, so now we know that A is a knave, and we have to do this, so let's have which one? Can you do simple which one? Wow, I wish I used that earlier. Actually I don't want to use that. I want to be able to do cases on it. So this is going to be exact self-started limb, H of HA. This is going to be rewrite not H. And right, knight to knave, and that intro is going to be H of A and H. I made a mistake somewhere. This is stupid, cheating back and forth. But I don't care. It finishes the proof. Um, okay. Um, I think we just brute force this other way. Okay. I'm going to take a short break and resume this later. Okay, we're back. So, as always with these problems, we're just going to brute force. So knight or knave Robert. And we're disconnected from the server, so we have to reload. Actually, we probably won't. Let's so we do have knight knave. What is causing this supposed to be so out? Actually, here's something else. We also, you know what? Let's just brute force this. moving on. I want to dispatch on A because so like A says stuff which will give us B, and then B. Then once we get B, we can use B says stuff. So let's dispatch on A. Okay. Second case is knave. Okay, we're done brute forcing. I need brute force on A again, because once we have A, we know what B is, and then so we know A and B, and that should be enough to. Let's just brute force on C. Okay. So if you dispatch on A, and A is a knight, that's easy to eliminate. Because then we prove that A is a knave. And then if we dispatch... Alright, let's just dispatch on this stuff. Okay, so A is a knave. And then we do case B. So case B, if B is a knight, then we use exactly one's a knave. We prove that C has to be a knight. And then B, if B is a knave, it contradicts that. Okay, so this works, and it's just a lot of grinding. No, this doesn't work. We want A the knave and we want C the knight. So H2 dot left and H2 dot right dot right. Okay. So if B is a knight, it's a trivial case. Um, then we get that B is a knave. Yeah, I think this is pretty straightforward. So, let's dispatch on. So let us dispatch on B first. Okay, that worked. Alright, so now we get that B is a knave. And let us now dispatch on A. What did I do wrong back here? What am I not getting right? Crap. What am I not getting right? H1, H3. H1, H3. Okay. We should dispatch on C first, because once we know C, it forces B, and then we'll just go from there. Do X falso? We don't. But it doesn't really matter. At this point, we just have to break this apart. In a separate world, we'll have anyways, back to this world. We're looking for contradictions. What is going on here? Ah, this knight and this knave needs to be flipped. Okay, we should get a contradiction out of this fairly quickly. Alright, we're using left underscore 1. Okay, we have an error somewhere. Where is our error? Why is this not done? Okay. Alright, that finishes everything. Pretty much all by brute force.